So my dear student, this could help us to get the moment of inertia for the perpendicular axis theorems. So the distance r of the particles m started at p x, y from a point 0 can be expressed as this one. Kwa tuweze kupata distance of the particles which is situated at the point x, y. Kwa tuweze kupata hii distance ya kutoka kwenye center mpaka kwenye ile point yetu, we could involve at the axis. It means tuta involve at the x axis and also the y axis. Kwa tutasema sasa kwamba tuweze kupata distances through the center to the point where the particle is located. We could say that r square must be equals to x square plus the y square. But here we use the concept of the Pythagoras theorem. Tumetumia concept ya Pythagoras theorem kwamba a square plus b square is equal to r square. But here the resultant is r. Now we could say that r square must be equals to x square, then we add by the y square, as we try to see here. So then the moment of inertia of the particle at point P about z axis is given by this one. Lakini sasa how can we get the moment of inertia of the particle located at point P which involve the coordinate of x, y? It can be involved, it can be obtained by taking mr square. It means the point where the axis of rotation started, which is equal to m times the x square we add by y square. Now we are going to demonstrate the formula of obtaining the moment of inertia through the z axis and also the summation of that along the x axis and also the y axis. So the moment of inertia, my dear student, of the whole planar body about the z axis is equal to the sum of the particles of mass a at a distance r can be expressed as this one. So we are going to see how can we obtain that formula. As we see that here, if we open the bracket here, that we could say that from our r square is equal to x square plus y square, we tried to introduce mass throughout. Kwa tumejaribu kuintroduce mass, ndio tukapata mr square is equal to m bracket x square plus y square. Kwa tukijaribu kufungua mle ndani, tukijaribu kufungua bracket hapa tutapata kumbe mr square is equal to mx square we add by my square. But mr square represent mr square here hapa represent the distance. That is what we are going to try to demonstrate. So if we consider all of the particles that are found inside the planar boards, inside the planar rigged boards, we should say that that particles must be placed, must contain the mass I. It means the mass of any particles. If we have many particles, and also their distance should be represented by r a. So finally, we could say that moment of inertia along to the axis must be equals to the summation of the mass of summation of the mass I we times by the ri square, where the I started from 1 up to the n stems. It means kwamba tunapokuwa na particle nyingi tutaziorozesha kutoka particle ya kwanza mpaka particle ile ya mwisho kama anavyojaribu kuonyesha. But we are supposed to say that we know that r square we have been obtained, which is equal to x square we add by y square. Now we are supposed to substitute r square equals to x square plus y square. If we substitute here, we should obtain that moment of inertia along to the z axis must be equals to the summation mass of any particles we times by xi square we add by y square. If we open the bracket, we should obtain that moment of inertia along to the z axis must be equals to the moment of inertia through moment of inertia along to the I axis, then we times by the x axis along to I, then we add by the summation of the mass I we times by the y axis or by the y square. But this should be our equation number 51 for our fourth topic. Hii ni equation yetu ya 51 kwenye hii topic yetu ya 4. So after this one, my dear student, what we are supposed to do baada ya kudemonstrate hapa kwamba moment of inertia along to the z axis ambayo ni sawa na summation ya along to the x axis, and then we add by the moment of inertia along to the y axis as we try to see. But we know that the sum of mass I xi square is equal to the moment of inertia along to the y axis. Kwa huyu summation wa mass I times the xi square atakuwa ni sawasawa na moment of inertia along to the y axis. So this should represent that the moment of inertia of the whole bodies about y axis. Kwa hii hapa sasa along, kama tunavyoona kwamba distance yake itakuwa ina look for them xi as we try to see on our figure, tutasema kwamba hii hapa ina represent sasa ni moment of inertia about for the whole bodies about the y axis. But this summation of mi yi square, this could represent the moment of inertia of the bodies about the y axis. Kwa hiyo hapa itakuwa ni moment of inertia about the x axis, kwa sababu hii ya kwanza hii kwamba inapokuwa na product ya x hapa itakuwa ipo ina focus kwenye y axis, kama tunavyojaribu kufocus kwenye hii figure yetu ambayo tumeonyeshwa hapa kwamba along to the x axis hapa huyu along to the x axis atatupatia moment of inertia ni sawa na summation of the mass I times the xi, lakini along to the x axis here ataweza kutupatia moment of inertia ambaye atakuwa ni sawa na summation of the mass I we times by the distance along to the y axis. It should give us the moment of inertia along to the x axis. So after this one, my dear student, what we are supposed to do here, baada ya kuona kwamba zile summation kwamba inapokuwa na product ya xi ila represent along to the y axis ambapo ni moment of inertia yake, na inapokuwa na product ya yi ita represent ni moment of inertia ya ile ita represent moment of inertia ya x axis. So this is the moment of inertia of the whole planar about the x axis. Therefore, the moment of inertia about the z axis can be expressed at this one. So after assuming that those product represent their moment of inertia, now we are supposed to turn back and substitute kwamba instead of writing summation of the moment of inertia, which instead of writing this sum mix square, we could write as the moment of inertia along to the y axis. Also, instead of writing summation of mi yi square, we are supposed to substitute equals to moment of inertia along to the x axis. So we could conclude by saying that moment of inertia through the z axis is equal to the moment of inertia through the y axis, then we add by the moment of inertia through the x axis. This will be our formula of obtaining the moment of inertia along to the z axis. So as the law said here, we could conclude by saying that xz must be equal to iz must be equals to ix, then we add by iy. So on this discussion, you will be asked some questions that try to state the moment of inertia, state the law, the perpendicular axis theorem. Unaambiwa kustate perpendicular axis theory task ya kwanza, lakini task ya pili unaweza kuambiwa kwamba can you prove that the moment of inertia through any axis of the coplanar rigged body nimezima maana nimeona